When we have a light ray that is transmitted towards a boundary, it's traveling towards a boundary, and here the electric fields are all in all sorts of directions. But when the refracted ray and the reflected are 90 degrees from each other, then the light that's reflected becomes polarized, and all of the light electric fields go parallel with the surface. And this only happens when this is at 90 degrees. So let's see how we can calculate this Brewster's angle based on the angle of the light coming in and on the values of the refractive indexes. So let me clean this up a little bit because I'm going to have to draw here. So we know from Snell's law that N1 sine theta p is equal to N2 sine of theta refracted. And we can see that theta r is just equal to, I'm sorry, I'm not writing here, we got the sine. So theta r, here's theta r here, and this is 90 degrees, so we have this angle here that I would like to find. We'll call that theta 2. And so that's just equal to 90 degrees minus theta 2. Now again, well, theta 2 is just this angle, and then we have theta 1, and these two make up 90 degrees. So I know that theta 1, or theta 2 is equal to 90 minus theta 1, so I can put that in here. And that just simplifies down. And I have 90 minus 90 is 0, and a negative minus theta 1 gives me theta 1. But theta 1 is complementary to theta p, because the reflected angle is going to be the same as the incident angle. So now I have N1 sine theta p is equal to N2 sine of 90 degrees minus theta 1. But whenever I have a 90-degree shift, I can make that a cosine. Oh, this should be theta p, I'm sorry. And now if I take and divide around, I can have sine theta p over cosine theta p is equal to n2 over n1, and the sine over cosine is just tangent of theta p is equal to n2 over n1, so theta p is just the arctangent of n2 over n1. And so now we can find the angle theta p that we need to have to be able to get this right angle at this boundary between the reflected and refracted. Get that to be 90 degrees, and we know that our reflected will be polarized.